No, we haven't reached AGI, but something did happen. In just the first 7 months of this year, AI passed new intelligence tests, began acting like autonomous agents, and started doing things most people thought were a decade away. So, here we are with the 6 breakthroughs that prove 2025 was the tipping point. 1. ChatGPT Agent Mode. For years, AI has mostly just talked. You ask it a question, it answers. Maybe it writes something. Maybe it explains something. But then, in July 2025, OpenAI rolled out Agent Mode inside ChatGPT. You can now give it a prompt like, summarize the last 3 emails for my client and create a presentation for tomorrow's meeting, and it will actually go do that. It'll read your emails, grab the key points, open up Google Slides, build a deck with titles and bullets, add visuals if needed, and save it to your drive. Then it'll let you know it's done. And this is just one example. It can open your calendar, book appointments, search the web, organize folders, and the list just goes on and on. On something called Humanity's Last Exam, a test designed to push AI systems to their limits with complex, open-ended reasoning, it scored over 41%. That puts it in the same range as some of the most advanced reasoning models out there. What's even more important is how smoothly it works. There's no special interface or tool you need to install. It's just part of the ChatGPT app now. You upload a file, write what you want, and it handles it. It doesn't ask you to guide every step or rephrase your prompt 5 times. And yes, OpenAI added safety features. It won't run dangerous code or access sensitive files without approval. There's a live system watching for risky behavior. Memory is off by default unless you turn it on. 2. Claude 4 by Anthropic. The second major breakthrough this year came from Anthropic. In May 2025, they released Claude 4, and it stood out for one very specific reason. It can actually think through complex tasks, and it can do that for hours without losing focus. The version that really impressed everyone is called Claude Opus 4. In testing, this model took on a full software development task. Yes, not a tiny demo, but a real-world code refactor with multiple files, multiple requirements, and multiple objectives. And it stayed focused on that one task for nearly 7 hours straight. It kept track of what it was doing and didn't fall apart halfway through. And it's not just a marketing claim. It backed this up with actual performance. On SWE Bench, one of the hardest benchmarks for software engineering, Claude Opus 4 scored 72.5%. Most advanced models struggle to even pass 50%, and ChatGPT 4.1, which was considered one of the top models until recently, came in below Claude. But what really separates Claude from the rest isn't just what it can do, but how it does it. It's a hybrid. So, basically 2 modes, one that responds fast for quick casual questions, and another that slows down and goes deep when the problem is complex. That means it doesn't waste time when the task is easy, but when something needs real thought, it gives itself more time to plan, reason, and verify the results. It also has a tool access built in that includes things like a calculator for math problems, a code interpreter for testing and debugging, and a browser-like system to help it find or organize information. And then there's the memory window. This part is huge. Most chatbots start forgetting what you said after a few thousand words. They lose track, repeat things, or need reminders. Claude 4 can hold over 2,000 tokens in a single session. That's, in layman's terms, equivalent to an entire book, or even multiple books. 3. Gemini DeepThink. If there's one area where AI usually struggles, it's math, especially problems that require multi-step thinking, logic, and proof. That changed when DeepMind's Gemini model, running in DeepThink mode, competed in the 2025 International Mathematical Olympiad and crushed it. Now, for those who are unaware, IMO is the toughest math competition in the world for high school students. Gemini DeepThink tackled 6 problems there. It solved 5 correctly. That's a gold medal performance. But here's what's even more impressive. Most math AIs need to have problems rewritten into formal logic or simplified into steps they can follow. Gemini didn't. It read the natural language questions, reasoned through them, and generated full, rigorous proofs. That's because of a new capability DeepMind built into the model, parallel thinking. Instead of trying one solution path at a time, it explores multiple paths in parallel, checks their validity, and refines the best ones. Still not enough, it even uses reinforcement learning to improve its judgment over time, just like a human learning from practice. 4. Alpha genome. Let's go deeper now, all the way down to human DNA. Our entire body is built from instructions encoded in a long chain of over 3 billion chemical letters. These letters come in pairs, and they form what's called the human genome. Scientists mapped the full sequence years ago, so we know what the letters are. But here's the problem. We still don't really understand what most of them actually mean. Only a small percentage of our DNA directly tells our cells how to make proteins. That part we understand fairly well. The rest? It's called non-coding DNA, and for decades, it's been a mystery. Some people even called it junk DNA at first. Now we know it's not junk, it does important things, but we still don't have a clear picture of how it works. That's where Alpha Genome can give researchers an edge. It takes a chunk of DNA, and, just to make it clear, a chunk doesn't mean a few letters. It is up to 1 million base pairs at once. The AI then analyzes it in detail. It predicts where genes start and stop, how likely different areas are to be open or closed to the cell's machinery, and how various parts of the sequence are connected. For those curious, Alpha Genome uses a combination of 2 powerful deep learning tools to work: convolution layers for detecting those short, repeated patterns, and transformer layers for tracking longer connections and context. One of Alpha Genome's most useful features is how it handles mutations. You can give it 2 versions of a sequence, one normal, one with a small change, and it will tell you what that change is likely to do. That means researchers can test how a mutation might increase the risk of a disease or change how a gene behaves, without spending years in a lab. It won't replace lab work, but it cuts down the guesswork and speeds up discoveries that could lead to better treatments. 5. NVIDIA's Blackwell. It's no surprise that AI needs powerful hardware to function, and this year, NVIDIA delivered its most important upgrade yet, the Blackwell chip. Blackwell was designed specifically to support the next generation of AI models, the kind with trillions of parameters, far larger than what earlier systems could handle. With older chips, training these massive models would take too long, cost too much, or just wouldn't be possible. But with Blackwell, those limits are finally being broken. So how does it pull this off? It starts with the chip's tensor cores, special processing units designed specifically for AI. These new cores are about twice as fast at handling key tasks like attention, which is how AI figures out what parts of a sentence, image, or input it should focus on. Next, there's the Transformer Engine, another major upgrade. It allows the chip to work with 4-bit numbers, instead of the more common 16 or 32-bit numbers. Smaller numbers take up less memory and can be processed faster, so models can be quicker, use fewer resources, and still maintain accuracy. Memory is another highlight. Blackwell includes up to 288 gigabytes of high-bandwidth memory, HBM3E. That's 50% more than NVIDIA's previous top-tier chips. Crucially, all this power comes with gains in energy efficiency. NVIDIA even reports that in specialized data center setups, Blackwell-based systems can be 30 times faster than the last generation while using dramatically less energy. And to top it off, you can connect up to 576 Blackwell GPUs together in a single setup using NVIDIA's high-speed NVLink technology. This allows companies to build AI supercomputers capable of training or running the largest models out there. 6. Gemini Robotics. Last but not least, we have Gemini Robotics, the first serious sign that AI is moving beyond screens and into the real world. Built by Google DeepMind in 2025, it takes what Gemini 2.0 already did, which by the way is combining text, images, audio, and video into one model, and adds a whole new layer: physical movement. That means robots powered by the system can look at a scene, listen to an instruction, think about what needs to be done, and then physically do it. For example, someone can say, "Fold this paper like a triangle and place it in the box." The robot sees the paper, understands what folding means, figures out where the box is, and carries it out, even if it's never done that exact task before. It's learning how to generalize, which means it doesn't need to be pre-trained on every single object or situation. Doing unfamiliar tasks, adjusting when things change, and handling small, delicate objects. That's called generality, interactivity, and dexterity. Most robots are good at one of those, maybe 2. Gemini is trained to do all 3 at once. Then DeepMind added something called Gemini Robotics ER. The ER stands for Embodied Reasoning. That means the robot essentially can see the world in 3D, understands how far away things are, how big they are, and how to interact with them safely. They also released a version that can run directly on the robot's own hardware, so it doesn't need constant Wi-Fi or connection to a data center. You can teach it new tasks with just 50 to 100 examples, which is a big improvement over traditional robotics, where training often takes weeks or more. The fact that companies like Boston Dynamics and Apptronik are already testing this on real hardware shows how fast this is moving. Robots using Gemini are starting to understand the world like we do, and now they're starting to act in it too. If you want to stay ahead of these changes and actually understand what's happening, make sure you're subscribed. Hit the like button if you learned something new. Drop a comment with the breakthrough that surprised you most. And share this with a friend who still thinks AI is just chatbots. Thanks for watching. See you in the next one.